Today I will show you why we use the chi-squared test, goodness of fit, what it actually shows us, how to calculate these values and interpret these results, and finally, when we would use this test. In order to complete the steps of a chi-squared test, we have to use a specific equation. This simply states that the chi-squared value is the sum of the observed data, which is the data collected, minus the expected data, which is the data predicted squared, then divided by the expected values. Let's work this through an example. In one class of 75 students, 11 of them are diagnosed with depression. My question is, does this class fit the prevailing theory that 12% of college students are diagnosed with depression? Now let's go over the steps on to complete a chi-squared test. First step, we need to calculate the expected number of students out of the 75 that would be diagnosed with depression. This would look like this. Next, we will need to construct a table that looks like this. So the question is going to be, how close is our observed sample to what we might expect is our observed sample, far enough away from what we expected to really cast some doubt on this absurd theory that only 12% of college students are diagnosed with depression. Now let's go through the steps of calculation. Now, considering our test statistic provided below, and because we are doing a chi-squared test using a chi-squared distribution, we need a degrees of freedom, and this will be 1. Using the chi-squared test, we will need to take each of the observed values, subtract the expected value, and then square it. To add to the 64 minus 66, which is all squared and then divided by the expected value of the students who were not diagnosed with depression within the sample. After calculating this math, we get 0.505. To determine the question above, we will need to use the table in order to find our special number by applying our degrees of freedom and our level of significance. To conclude the findings, let's look at our decision rule located below. As you can see, the chi-squared value is not greater than 3.841. Therefore, we will have to fail to reject the null hypothesis.